Hello all, this is Sagarika. Welcome to SAGU'S Math. Today's topic is Divisional Algorithm. Given integer a and b with b greater than 0. Okay, a and b are two integers, b greater than 0. There exist unique integers q and r such that a equal to b cube r plus r. When we divide a by b, we know that there will be our quotient and there is our remainder. Okay, b a is equal to b into q plus dividend. This is our dividend. Divisor, q is quotient, r is remainder. Okay. The integers q and r are respectively called quotient. Always q and r is unique. And also r value is greater than equal to 0. Maybe it 0 or greater than 0. And always less than the divisor. Okay. Divisor is our divisional algorithm. Next to let a and b are two integers. Okay. To find the GCD between the GCD of a comma b, the Euclidean algorithm is desired. The Euclidean algorithm is desired. Okay. So what are the procedure for finding GCD by Euclidean algorithm? Okay. From divisional algorithm, when we find the GCD between two number a comma b. Also, this is equal to GCD of modulus of a comma modulus of b. That implies we can say a greater than b. A greater than equal to b. We divide a. When we divide a by b, that implies a is equal to q1b plus r1. Okay, r1 is less than b, greater than equal to 0. Here two conditions will arise. If r1 equal to 0, that implies a divide b. That means a is divisible by b. Okay. Here GCD is equal to b. If r1 not equal to 0, that if r1 not equal to 0, then divide b by r1. That means they are introduced to integers q2 and r2, quotient and remainder. Okay, which equal to b is equal to q2 r1 plus r2. Okay, where this is remainder, that means r2 less than equal to, here is quotient 0 less than q2. Okay, sorry, less than r1. Okay. Next two condition will arise. If r2 equal to 0, then GCD is equal to r1. Then GCD of AB is equal to r1. That means the previous remainder is our GCD. This is one step, this is second step. Next, if r2 not equal to 0, then divide r1 by r2. Okay, r1 is equal to q3r2 plus r3. Okay, here q3 quotient, r2 our divisor and r3 our remainder. Same condition will happen. 0, here is our r3 remainder less than r2. Okay, this is step 3. Similarly, the procedure repeats if R2, R3 equal to 0. If R3 equal to 0, then R2 GCD of AB is equal to R2. Okay. If R3 not equal to 0, then divide R2 by R3. Similarly, we can write R3 is equal to Q4 R3 plus R4. Okay. Where 0 R4 is greater than equal to 0, less than equal to R3. The above procedure happen, and finally when we get Rk plus 1 equal to 0, then Rk is our GCD. Rk value is our GCD. Okay. Let's move to do a problem. The result of a Euclid algorithm was A is equal to, here equal to A, this equal to B. A is equal to Q1B when we divide A by B. Okay, here, there is quotient Q1 and remainder R1. That implies we can write A equal to Q1B plus R1. If R1 equal to 0, then GCD equal to B. If R1 not equal to 0, then to move seconds. Okay, that implies divide B by R1. Okay, B is equal to Q2 R1 plus R2. Similarly, if R2 equal to 0, then GCD is equal to R1. If R2 not equal to 0, that implies divide R1 by R2, which equal to Q3 R2 plus R3. Similarly, the procedure was followed. Okay. Now, write this. 3054 divides 3054 by 162. Okay. That implies 3054 equal to, here 3054 is equal to 18 into 162 plus 138. You may check the result. Okay. That implies this is our A and this is B. This is our Q1. Here is R1. Okay. Next step is R1 not equal to 0. Here R1 not equal to 0. That means divide B by R1. That implies 162 is equal to 1 into 138 plus 24. Okay. Here 162 is our B. According to second step, B is equal to Q2. This is R2. This is our R3. Sorry. This is R1. This is our R2. Okay. Here R2 not equal to 0. R1 138 by R2 which equal to 24. That implies we can write 138 is equal to 5 into 24 plus 18. Okay. This is our R3. This is our R2. And here is R1. This is Q3. Okay. Here R3 not equal to 0. That means move to next step. Next step to divide R2 by R3. 24 by 18 is equal to, we can write 1 into 18 plus 6. Okay. This is our R2. Okay. Here is R3. This is Q4 and this is R4. That implies here R4 not equal to 0. Then divide R3 by R4. That implies 18 by 6. Okay. Which equal 18 is equal to 3 into 6 plus 0. Here R5 is equal to 0. That means this is R5. This is R3. Here is Q5, R4. Okay. That implies R5 is 0. From Euclidean algorithm, we know that the previous remainder value, the value is 0. Okay. Here R4 is our GCD. R4 is our GCD. That implies GCD of 3054, 162 is equal to 6. Okay.